density. Okay, so that's why in the 4-season country, you have a heater, and the heater will sit at the bottom of the wall. So this is heater. As compared to the in Malaysia, we place our aircon on top of the wall. This is AC, this is heater. So why? Because heater will give you hot air, so hot air will go up. So it will heat the room. And air conditioning system, the air is cold. So because the density is higher than this one, so the air will go down. So imagine if you put a AC below and heater on top, you wouldn't achieve the objective that you want. You cannot cool the room, you will cool this region, not up to the whole room, because the density of air is high, so that you only cool, you are trying to cool only the bottom region. So with respect to that, we are looking at different density with respect to Archimedes principle of buoyancy force. So we come up with the equation over here. The most important thing is this force that holds the ship is basically due to the different density. Okay. So before we look into natural convection, let's look into several couple of additional parameter that we need to use for natural convection. Oh, sorry, I need to record this. All right. So we have a volume expansion coefficient. Okay, volume expansion coefficient. So we have a large beta, small beta. Okay, so if we heat this by different in temperature by 1 degree C, you see over here from 20 to 21. This is for also from 20 to 21. Delta T is 1 degree C. This one expands much more larger than this one, because in this case, this gas has large beta or large volume coefficient as compared to this one, which has small volume coefficient. So how to calculate your volume expansion coefficient is basically your 1 over your TF in Kelvin. Okay, we're going to look at this parameter after this. Just I want to highlight is we have a volume expansion coefficient to determine how much the expansion would be. So heat transfer rate in the natural convection depends on delta T. So T surface minus T ambient. Of course, if we look at the basic fundamental equation is HA T minus T ambient. If you want to increase this one, the difference or delta T must be higher. Okay, so increase in buoyancy force will increase also heat transfer rate, convection current in with respect to laminar or turbulent. So turbulent will give you high heat transfer rate. We have mass flow rate control by friction, and then we have viscosity over the fluid for air. So if the mass flow rate decrease, a high friction. Okay, with the on contrary, if you have high buoyancy force, the mass flow rate will increase. Okay, so let's look at how the temperature profile and the velocity profile acting on the flat surface. So let's say this is a flat surface. So where T surface is much more, temperature of T surface is much more higher than the ambient. So 50 degree, and this is 20 degrees C. So heat transfer will be in that direction. Okay. Due to a no slip boundary condition, again, developing a velocity profile, and you, after certain point, and you will get a velocity profile that looks like this, fully developed. And the temperature profile will look like this. Okay, higher from the one side and similar as the ambient temperature at another side. So this is for case surface larger than ambient. So how the temperature profile looks under the reverse case? So you just simply reverse the shape. So this is for, let's say, T ambient larger than Ts. So the temperature profile will look like this, but the temperature profile remain the same because the temperature does not affect the velocity. Okay, we have looked into volume expansion, volume coefficient for expansion. So next we are going to look at the Grashof number. So if you are working with natural convection, we need to know the Grashof number. So the Grashof number is given by this equation. So the gravity 9.81, beta is your volume coefficient expansion 1 over T F. T is your T surface, T ambient your T ambient, LC your characteristic length, and V is kinematic viscosity. So this is another parameter, more or less similar to Prandtl number. You can call that, but Prandtl number you can get it from table, but Grashof number you need to calculate by using this equation. So what is Grashof number? So basically it tells you about the main criteria whether the fluid is laminar or turbulent in natural convection. So we are talking about natural convection. So Grashof number will give us indication whether the flow is laminar or turbulent. So you cannot use Reynolds number to rate laminar or turbulent in natural convection. So in fluid mechanics, yes, you have laminar, you have turbulent. This based on Reynolds number. But for natural convection, for laminar and turbulent, you need to look at Grashof number or GR, in which you need to calculate by using this equation. So for vertical plate, critical 1 to the power of 9. So anything larger than this, we consider is a turbulent. And then apart from this explanation, so Grashof number is also a relative magnitude of the buoyancy force and the opposing force. So if you have a hot fluid, it will move up, right? But at the same time, your fluid has viscosity, and the viscosity acting on the plate, which cause friction force. So you will be having like a one forcing up or one another forcing down. So if both are similar, nothing happens. Okay. If the buoyancy force is much more larger than friction force, this will go up. So Grashof number is a relative magnitude for that. So okay, we look at natural convection or the technical of natural convection, and we want to compare with the forced convection. Before going to this, let's see this image first. So you can have natural convection, purely natural convection. You can have a mixed convection because you have a force of air over here, which give you natural convection plus forced convection. Okay, and over here you can have only forced convection. So the mix of natural convection and forced convection is given by this criteria. So you need to calculate what is your Grashof number and divide by your Reynolds number to the power of 2. If the ratio is less than 1, so your problem is dominated by forced convection. So you don't have to use the Grashof number. You straight away go into an external or internal forced convection. So if your ratio of Grashof divided by Reynolds number to the power of 2 is significantly larger than 1, so you need to consider your problem as a natural convection. Therefore, you need to calculate your Grashof number, you need to calculate your beta or volume expansion. So if your problem, your ratio of Grashof number to the Reynolds number is more or less equal to 1, or maybe 0.89 or 0.95, you need to consider both. So apart from forced convection, you need to also include natural convection. Okay, this is how you tell or you rate your problem based on this ratio, whether you want to include only natural convection or only forced convection or mix of both. So now we are looking at the equation or the technical content of the natural convection. So in general, it is same as a forced convection. Okay, you start with having correlation. Okay, apart from this chapter, natural convection, the correlation will be different because we are working with different problem. Okay, but in general, the process are the same. You choose the correct correlation for first convection, so for natural convection, and this is equal to HL divided by K. You know the K value, you know the characteristic length, you will determine the H. And this also depends on the geometry, the orientation of your problem, physical properties, and the surface temperature. Okay, so if we recall back your knowledge in force convection, so this is what we going to look at. So we have a different correlation for different cases, different Reynolds number. But in this case, for natural convection, what you need to calculate is Grashof number first, and then you multiply with rounded number. So this is Grashof number. You have looked into this a couple of slides before. And then if you multiply this by rounded number, this you can get from table. What you can get is new parameter, Rayleigh number. So Rayleigh number is so this Rayleigh number is based on Grashof number multiplied by rounded number. So from this, you have a correlation. We look into the correlation after this. And this is equal to HL divided by K and find the H. So the power depend on the cases. If laminar, 1/4, if turbulent, 1/3. And then when the average Nusselt number is known, from this correlation, you will get the Nusselt number, because this is equal to Nusselt number. The rate of heat transfer by natural convection, basically Q, from a solid surface at a uniform temperature T surface to the surrounding is expressed by this equation. Why? Because after you obtain your Nusselt number, you can calculate your H. Once you get your H, you can put it over here. You can calculate your rate of heat transfer rate by natural convection. Okay, so this is the correlation. So what you need to do is to calculate what is your Rayleigh number, okay, which involve two parts. First, you need to calculate your Grashof number. You need to calculate this first, and then you need to look at the table, the value for Prandtl number, and then you multiply both the Grashof number and Prandtl number. You can get your Rayleigh number, and you look at your range of Rayleigh number. But first, the basic thing you need to look at your geometry of your problem, whether it's vertical plate, inclined plate, horizontal plate, vertical cylinder, horizontal cylinder. So the first thing, look at the geometry. From your geometry, you can have a multiple correlation. In this case, you have a couple of correlation over here. And then you calculate the Rayleigh number, which contain Grashof multiplied by Prandtl. From here, you can choose which one is suitable for your problem. So next, this equates to HL divided by K. Find your H. And then input into Q equal to HA delta T. And you can get the Q. So that is the basic of natural convection. The process more or less similar with the force convection. Okay, let's look at the first one, which is the vertical plate. So if your Rayleigh number fall under this category, so let me zoom this in. Okay, fall under this category, this is the the correlation for Nusselt number. So under this category, you use this one. But if you don't want to look at this one, you just want to go straight ahead, calculate, yes, you can. So what you are going to look at or using is this equation. So you are going to use this long equation to calculate your Nusselt number. Both are valid, both regions are valid for this one, but it's a bit long, complex, but more accurate. You can use this one, no problem. If this fall under this category, you can also use this one. But if you calculate your Rayleigh number between this region, but you use this one, also correct. Okay, it is complex, but more accurate. It's still acceptable. Okay. So for inclined plate, you use vertical plate equation. You use this one for upper surface of a cold plate and the lower surface of a hot plate. So we replace this G by G cos theta. So let's say you have a vertical plate originally, and your problem is inclined plate. So you need to multiply G by G cos theta and use this correlation. For horizontal plate, you have two different things. Depend on where is your hot surface. If your hot surface is on the top, you use this one. If your hot surface on the bottom, you use this correlation. So make sure you define your hot surface.
Doktor,
Yep. Oh, I
kami
see.
ada
Dia punya
nampak slide.
screen tu white Tak ada keluar apa-apa
Tak ada keluar apa.
Oh, sekejap.
Putih.
Alright, sekejap. Hmm. Okay, nampak tak sekarang? Rasa okay dah kan? Sebab saya
Nampak.
zoom in tadi kot. Sekejap. Alright. Saya repeat balik yang missing tadi tu. Sebentar ya. Okay, back to the Rayleigh number punya correlation. Okay. Kalau the first thing you need to look at dekat column this one. This column, geometry ni lah. So what is your problem? Vertical plate ke, inclined plate ke? So if you vertical plate, you look at the Rayleigh number. So Rayleigh number ke from this equation. Okay, it come from this equation. Which range? Kalau tak nak pening pakai which one? Tapi still you kena calculate juga Rayleigh number tu. You can use this more general correlation. This is more general. It fits lamina and turbulent. Cuma nak calculate dia tu, you need to calculate one by one sebab dia ada power 9/16 kat sini. And then 8 to the 27, so quite tedious. If you don't want to use this based on Rayleigh number, you can feel free to use this one. So if inclined plate, we are using the same vertical plate equation. Apart from G ni, in the Rayleigh number equation yang we use here, we replace with G cos theta, depend on the angle. So for horizontal plate, all right. So it is important for you to define which one is hot surface. So if the hot surface on the top, you use this part. If hot surface on the bottom, you use that part. Okay. And then for horizontal plate, your characteristic length is A surface divided by perimeter. So if you look from the top, okay, let's say macam ni. AS ni adalah dia punya A surface atas ni. Sini A, B. Dan perimeter dia adalah 2A plus 2B. Okay, area dia adalah A square. This is A, this is the perimeter. Right. So kalau dia vertical plate, you just use the total length of the plate. So kalau di horizontal saja, dia akan jadi macam ni. Characteristic length AS divided by P. Alright, that is for flat plate. So we also have a vertical cylinder. So if you problem geometry in a vertical cylinder, ada note sikit kat sini. A vertical cylinder can be treated as a vertical plate. So meaning that ni, vertical cylinder ni, you can treat as a vertical plate punya equation. Okay, this is a vertical plate punya equation. Vertical plate lah, ni boleh approximate to vertical plate. If, ada if kat sini lah. This is the criteria. So if dia punya diameter ni adalah lebih besar daripada 35 multiplied by its L divided by ratio of number to the power of 4. So kalau kriteria ni meet, you can go ahead pergi kat vertical plate and use dekat sini correlation mana yang sesuai. Okay, so that is for vertical saja. Kalau vertical cylinder. Kalau horizontal cylinder tak boleh pakai vertical cylinder punya flat plate punya equation lah. Bila horizontal cylinder, we have the equation itself. Vertical saja kita boleh view as a vertical cylinder as a vertical flat plate. Horizontal cylinder, we cannot use horizontal plate. So only vertical cylinder sahaja. So sekali kita tak sentuh, kita up to horizontal cylinder. So, okay, kat sini ya. So vertical cylinder can be treated as vertical plate if this is the condition. Kita kena met dulu. Maknanya kita kena satisfy, we need to calculate this and show the diameter of this one. Oops. Okay, the diameter dia sama dengan 35 multiplied by the length divided by the Grashof number 1 to the power of 4. And then we can move to this equation in which this equation becomes valid for your vertical cylinder. Alright, so kita akan tengok kenapa hot surface atas dengan hot surface bawah equation dia lain. So the explanation will be due to the buoyancy force. Okay, if for example TS surface is much more larger than T ambient, okay, top surface the heated fluid rise freely, we have a high heat transfer rate. So Q dia lebih tinggi dekat atas as compare dengan Q dekat bawah. Sebab dia Q kat bawah ni dia block by the surface. Sebab ingat bila hot air, dia punya tendency will go up. Sebab dia punya density adalah rendah. The tendency will go up. But it's blocked, therefore high dekat atas or top surface high transfer rate, dekat bawah low heat transfer rate. So what happen if ni case ni untuk KST surface lebih tinggi daripada T ambient. So let's assume this 50 degree C, T ambient 20 degrees, 25 degrees C. So heat transfer keluar ke atas lah. So daripada from hot to what happen if TS yang T ambient lebih besar. So let's say T ambient right now 50, T surface 25. So the opposite happen. So all the arrow you can turn in the reverse. Okay. But normally this is much more popular lah. Yang hot surface, yang flat plate atau hot surface daripada ambient. So this is why we have different correlation for, even though similar problem, tapi hot surface kat atas dengan hot surface kat bawah, we have different correlation because of this different heat transfer rate. So the parameter, okay, this one, the table, sama juga dengan hot cylinder. Okay, we have variation because of the boundary layer start from bottom. So the thickness dekat sini, thickness of boundary layer ni different from bottom to top. Okay, top ni lebih besar daripada yang bawah. And we have a highest local bottom ni, highest nasihat number dekat bawah, and then kat atas ni nasihat number kita rendah. So bila nasihat number kat bawah ni tinggi, okay, highest nasihat number, so H kita pun akan tinggi, so Q kita pun akan tinggi as compare dekat region bawah. So kat bawah ni lebih sejuk sikit. Bukan lebih sejuk, heat transfer rate tu lebih tinggi. Okay, because of heat transfer coefficient kita tinggi as compare to the top. So in your final exam, this will be given. So final exam tak perlu bawa appendix, no such thing of bringing the appendix thermodynamic property tu dalam exam online nanti, tak perlu buka pun. Sebabnya dah diberi, and then dia lebih mudah lah dah diberi tu sebabnya because of if your problem within this region, so your value will be in this region aja lah. So we are not giving you the whole range, so save you a lot of time. Okay, so tak adalah tersilap untuk kira TF tu kan, sama dengan TS tambah T ambient bagi 2. So that this TF value will be given based on the smaller range, not range we need. But you need to familiarize yourself with this table. Okay, where you need to pick your density, your thermal conductivity, okay, your kinematic viscosity of rounded number. So these 4 things are important for natural convection. Right, let's look at one example. Very basic one. So kita ada horizontal hot water pipe. Okay, temperature ambient 20, 70 on the surface. Determine the rate of heat loss by natural convection. Okay. So if natural convection, by natural convection ni for sure there's going to be a Rayleigh number punya calculation. So first we need to look at the T film. T film is basically T surface tambah T ambient divided by 2. So in this case, kita punya value adalah 45 degree C. Ni air, okay. Kat sini 45. So all the value kat sini lah. Yang you akan ambil masuk dalam this problem. Okay. Apart from this daripada table, beta ni you kena calculate lah. Atau volume coefficient, volume expansion coefficient. So this is basically 1 over TF. So your TF ni 45, but tambah 23, you need to calculate this in Kelvin. So 1 over 318. So beta ni does not come from table, you need to calculate. Because you will use beta in your Rayleigh number punya calculation. So this is okay. So Rayleigh number is a compilation of consists of rounded number dengan ni. Saya pun tak lupa nama dia sekejap. Rayleigh number, Grashof number. Okay. So Rayleigh number ini adalah combination of Grashof number dengan rounded number. Dapatlah Rayleigh number. Grashof number low ni tak boleh untuk determine the problem because all the tables over here depend on your Rayleigh number. That's why you need to multiply your Grashof number with rounded number. Okay. So from here, don't forget your beta ni, volume coefficient nak masuk dalam ni. Then from there you can get your Rayleigh number. So tengok dia punya geometry, this is a cylinder, horizontal. If horizontal, okay, sini kita pakai correlation this one, less than to the power of 12. This is the correct correlation. Right, so we use that, and then kita dapat dia punya Nusselt number. So remember that Nusselt number is HL divided by K. Okay, and then we rearrange this in which we want to calculate the H. Right, K dah tahu from the table. Dia punya L adalah diameter dia. And kalau you tengok dekat sini, dia punya value of H, this is very low. Okay, 4.8. As compare kalau you buat problem force convection, normally 25, 35 and above. So because this is natural convection, the heat transfer coefficient very low. So 5 point something. And then you can calculate your area surface area pi dl. Okay, you know the H, the S, and you can calculate your. Alright. So I would suggest that you look for final exam. In terms of difficulty, not difficulty, I would say in terms of ease of calculation, natural convection is much more straightforward. But the understanding of natural convection is some time. You need to read the book to really understand what ratio of number, what the ratio of number, Prandtl number is all about with respect to the natural convection. So, like example ni jadi add juga radiation, tapi we don't cover this one. So we only cover specifically on natural convection saja. Alright, so that's all for this topic for natural convection. Okay, I just want to recap. The first thing you need to look at the geometry. Okay, there are some cases that you need to prove something. For example, this one. If your problem is a vertical cylinder, because you don't have equation for a vertical cylinder, therefore you need to prove that the diameter is larger than this one, and then you go back to the vertical plate, choose your correct Rayleigh number, choose your correlation, equate with HL divided by K, find the H, and calculate the Q. So basically similar to force convection. Okay, so technically we are done with all syllabus for your this SEMM 2433 ni. Okay, so next week belum study week kan? So kita akan buat a bit of online punya tutorial similar time, similar day, next week Rabu for final exam. So we'll cover a couple of question with respect to this one. And then kalau ada apa-apa soalan ke yang you nak tanya tak clear, kita akan discuss bersama lah dalam online session.